Hey folks, it's Andrew from Gemba Red, and today we're going to be doing LED heat lamp therapy part 4. We've got a nearly identical setup to the past 3 days, except this time this lamp is an 810 nanometer lamp, so it's all 810 nanometer LEDs. And again, it's a very high intensity, so it's going to cause a thermal effect, and it's not a photobiomodulation effect. And so we're going to see how much temperature increase we get when we use a high intensity LED heat lamp. Now, theoretically, and from the research I found in the science, 810 should be the least heating wavelength out of all the wavelengths in the solar spectrum, because 810 has the least absorption, and that's why we get the best penetration. So the least absorption means it penetrates a little bit deeper, the light gets diffused, and your body has more of an opportunity to thermoregulate. So 810 is the least heating, according to the theories, less than red, less than blue, less than obviously far infrared. So, we'll test that theory out. So let's just go through our measurements and setup. We're just going to verify the wavelength. It looks like about 6 inches away I did, but here we see we're up around 93 milliwatts per centimeter squared, so that's nice and scorching hot. And then we verify the peak wavelength is 811.9, so almost 812, so that's pretty good. That's right on. So yeah, we're ready to go. Okay, let's look at the power from the Thorlabs power meter. We're reading about 433 milliwatts, and so we're going to divide that by 3.8 to get the intensity. So we're looking at 113, almost 114 milliwatts per centimeter squared. So again, that's nice and toasty, about the same as what we used for the 850 and the 660 in previous videos. So that'll be a good measure of how much heat we're going to get from this 810 nanometer wavelength. And okay, you can see the ambient temperature is 21, and we'll check the arm temperature. So 36, like right on the spot there, so that's good for me, typical for me. Okay, let's get started for another thrilling video on our Gemba Red YouTube video, where I sit down and take temperature measurements. Okay, almost the 1 minute mark, feeling nice and warm. Oh yeah. So we got 36.8. It's a nice little bump up, 0.8 degrees already in just 1 minute. Okay, almost 2 minutes. Oh, that's pretty quick. 38. So we get about 38 here. Yeah, still 38. So, big temperature jump in just 2 minutes, got 2 degrees. So 3 minutes. Let's get in there. 40. That's fast. 39.9. 39.8. So yeah, that's real fast. All right, let's do 4 minutes. 40.9. 40.9. So yeah, that's really heating up. All right, let's check 5 minutes. 41.7. Oh my goodness. 41.4. 41.1. So yeah, 41.1. So that is getting real hot in just 5 minutes. All right, almost 6 minutes. 42. 42.0. So it's cranking. So yes, I do feel, the stinging sensation, the, kind of sensation like, hey, maybe this is a little too hot. Maybe I should pull away. It's not really a good thing. Maybe a very gentle, mild warmth, like we showed with the 50 milliwatt setting, would be better. This is nearly 115 milliwatts per centimeter squared, which is extremely high. The studies are very clear that you risk overheating your skin. 42.6. So we're getting close to 43, which should blast past this for safety and really just be something that you need to avoid. All right, almost 8 minutes. 42.2, 42.7, 42.3, 42.9. So yeah, it's getting up there. We'll see, maybe at 9 minutes we'll get over the limit. Okay, almost 9 minutes. check it. 42.8, 42.2, 42.2. So maybe I've leveled off, or maybe something's kicking in. So I'm at 42.2, so that's good. I'm not, you're not blowing past it. Maybe I'm starting to level out. All right, almost 10 minutes. 42.8, 42.4, and high. So we've reached past 43 in some parts of my arm at least. But we can still get up around, close to 43. So it's still pretty high, but that should be enough data for this test.